Proprietary PSK authentication, also known as PSK authentication. Till now we have understood what PSK is, how we can enter a password from 8 to 63 characters, and then PSK can be easily configured on our home routers, right, to connect on the Wi-Fi. Now keep in mind that the simple PSK authentication method defined in WPA2 personal can be weak authentication, right, and is definitely vulnerable to a lot of attacks. Okay, so we know that PSK is a weak form of authentication defined under WPA or WPA2 personal. Now this can be vulnerable to a lot of brute force offline attacks and also social engineering attacks. Okay, so brute force offline dictionary attacks and also social engineering attacks. Okay, although passphrases and PSK authentication are intended to use only for SOHO, right, as we discussed in the last video, PSK is generally for SOHO use, so really doesn't matter if the password is compromised, right? You can always change the password for your home. But there are a lot of enterprises also in reality that still use WPA2 personal PSK authentication for their enterprise network. Now that's a problem because it could be because of many reasons. Some of them could be because the team doesn't have the capability to run a radio server. Cost could be an issue. Cost is a major driving factor sometimes. Cost can be a factor. They don't want to deploy and configure and install and support a radio server or .1x protocol. So cost can definitely be a factor why enterprises still use WPA2 personal PSK authentication, right? It is a very, very common occurrence. I've seen in multiple enterprise scenarios also where they happily use PSK, right? Now the biggest problem with PSK, as I discussed 2 minutes back, is that it is prone to social engineering attacks, right? A PSK is definitely same on all the WLANs. If a user accidentally gives the PSK to a hacker, the security is definitely compromised, right? If an employee leaves the company, so let's write that down. If a user correct that. Okay, if a user leaks the PSK, security is compromised. Now if an employee leaves the company, leaves the firm, right? If an employee leaves the company, now to maintain a secure environment, all of the devices have to be reconfigured with the new PSK. Now let's say you had around 1,000 users connecting on the PSK on the SSID. Now if one employee leaves, of course you can't risk it, so you've got to pretty much change the PSK on the AP and also on all the 999 devices or the next employee joining. So total of 100 devices you have to pretty much reconfigure the PSK. That's a hell of a task, right? So again very, very tedious work to do. Now because the passphrase or a pre-shared key is shared by everybody, a strict policy should be mandated for sure, stating that only the WLAN security administrator is aware of the firm. Which means if you have one person managing that PSK, right, now he has to go and configure it on all the devices. That's something which is a whole different problem to handle, right? Instead of giving it to the employees or dropping and just floating an email saying this is your PSK on the SSID, everybody can connect on their own. Now if one person is handling it, it becomes a hell of a problem anyway, so you can't really leave it with one person to go and configure all the devices. That's not going to fly. Now because of this particular problem, and trust me, it's a very, very practical issue that a lot of people face. Okay, now several enterprises, WLAN vendors, this is vendor specific of course, they have come up with a very creative solution of using this PSK and not using a single PSK for per MAC address. Okay, so what they've done is they come up with a very creative solution called a PPSK, a proprietary pre-shared key solution. Now each computing device or user will have its own unique PSK for the WLAN, right? Individual users can be mapped to a unique WPA2 passphrase. Now what happens is, what we're doing is, we have one laptop, we have two laptops, we have three laptops, we have an SSID called let's say SSID is security SSID that they want to connect on. Okay, now the good thing is that these SSIDs for each user, let's say it's user number 1, user number 2, user number 3. Now this user will have its own PSK. Let's say it's AA, BB, CC, DD, whatever, and this user will have a different PSK. Let's say it has II, JJ, KK, anything, and then this user will have its own unique PSK, which could be anything like A, B, C, D, E, F, something like that, right? So you get the point, right? So a database of unique PSKs mapped to usernames, okay, or individual users can be stored or must be stored on the access point or a controller, whatever you're using in the network, and that's pretty much how this is done. So these unique PSKs for each user, let's say this, there has to be a database maintained in the system, which talks about user 1 has this PSK1, user 2 has this PSK2, user 3 has this PSK3, and up to all user 1000 has PSK 1000, right? Now if one user leaves, okay, you just have to change that user's PSK. You don't have to change everybody's PSK. Okay, that's something which makes it very easy. And also these keys can be dynamically generated or manually created also. Depends on the network admin and what he wants. This can be done either way. Okay, this gives us the flexibility. Now anyway, so this is kind of giving you a lot of power in a way where you don't have to deploy an EAP solution, but you get the flexibility of that in a way, right? You get a different username password for basically get a different password for different user. So proprietary PSK solutions provide a way to implement unique credentials without the burden of using an EAP authentication protocol, right? So it's as flexible as a PSK, but it's not as secure, but it gives you quite a lot of security compared to PSK, right? So now this is something which is very good. So PPSK gives us flexibility as well, right, in a lot of ways. Now unfortunately some client devices have limited support for .1x EAP. In situations like these, PPSKs may not be implemented, right? Because some, as I said, it's a vendor specific solution, so some clients may not support it. That's where you pretty much will have to go and deploy EAP in the enterprise, but that's very rare because most devices nowadays do support PPSK, and most vendors have also come up with a lot of very creative PPSK solutions, right? Almost every vendor nowadays in the market does support a PPSK solution, and something which can be explored very much if needed, right? Some of them also have the flexibility to put a timer onto the PPSK where you can actually have that key generated only for 12 hours or only for 8 hours, or they have an expiration timer also with that. So that's something which again makes it very, very flexible, right? Right, so this was about PPSK. Now, I mean, my recommendation would be any network that is running PSK nowadays, as a network admin or as somebody who knows Wi-Fi security now, you should be able to consult with the customer, or at least advise the customer to move away from PSK and try to show them the problems that PSK can have, like social engineering and brute force offline attacks, dictionary attacks, and show them the benefits of PPSK and how PPSK can be flexible. Nowadays, any vendor, PPSK is more or less supported. So yeah, they should not be having a problem, and each device also should support PPSK. The radio cards are built that way, right? Cool. So anyway, the next thing that I want to discuss is EAP authentication. But even though it's a part of robust security network, I want to take it up in the next chapter, because EAP in itself is a big topic. So I'll cover that EAP part in the next chapter, number 5.